Everything is proceeding in line with my design. MrCrispin here once again, and welcome to my workshop. In today's video I'm going to be finishing the motion plates, which are the components I started in the last video, and to do that I'll be doing a range of milling, drilling and fitting. Now, a bit of filing remained at the end of the last video and I was going to do that off camera. However, I've had many comments from numerous people requesting to see more filing, so I thought I would begin by showing that filing on camera, and hopefully that satisfies the two of you who asked. So without further ado, let's make a start. Here at the vise I've amassed a small range of files as I've been working, and the task at hand is to make this end look like this end, and I'm doing that by hand. Now, work holding wise, I'm using a normal vise. This one happens to have pretty much smooth jaws, but I just lay this cloth over it just to stop bits getting embedded. Now I'm going to be removing this excess, cleaning the faces up and then blending a few edges plus general deburring. So a big part of filing is the angle of approach, both in terms of how you set the piece up but also how you go about filing it. With things like this, for instance, these thin, highly raised edges, if I file straight across it, not only does it make a slightly annoying sound, but also it tends to push everything over, and on this it doesn't really make any difference, but it's worth noting that if I file along instead, that effect becomes a lot less. And now I can still make pretty quick progress, but it's making a much more pleasing noise. The file's cutting nicely, and I'm not causing anything to distort. Always be careful running your finger along the line where the burr forms. That's the sort of easiest way to cut. Running your finger at 90 degrees is much less likely to cut you. Having got it down there, now I'll reposition and file across. Got a slightly sharper and finer file here just for seeing what I'm doing now. The name of the game is to, of course, stay flat, and also to consider how this blend happens here. So seeing as I'm getting close, I'm just going to take a smaller file and I'm just going to see where that blend actually lies. So I can see it's pretty much where I am now. Now I've got a little bit of a divot here where the solder hasn't quite filled, so I'm going to use a little artistic license and just take that out. Okay, so that's got rid of the divot and no harm done to the blend. Now that this is all flat, so to speak, I'm going to turn to some draw filing, and draw filing is the method moving the file like that. And then first of all I'm going to start by cleaning up the surface I've just filed acrossways, taking care not to dig in too hard on the return stroke, because remember this has to be a nice blend. But the purpose of this is just to show me how the surface is looking, and draw filing gives you a naturally flatter surface. So by my estimation, I'm slightly low round here, so I'm just going to return to a little cross filing to sort that out. The beauty with this kind of thing is there's no exact dimensions required, it's more about the finished look. Now I can feel the file is slightly clogging up. It's a very fine file, and so that happens, but you can see here I've got little particles embedded, so I'm just going to take a file card thing I'm watching is this level here. I'm watching how the two interact, and that's giving me my main source of information as to level. Okay, so before I go too far with that, I'm now going to take a little look at this, and using a round file I can just start having a go at this. A little bit more to take out here because I still have some cross filing marks. Now you have to watch it with these round files because it's very easy to dig a hole. But that's looking pretty good, and I'm now going to use smaller files from here on in. Let's have a look, something like this for now. One thing you can do here is use the file safe edge going into the radius and just let it ride round, and then at least it doesn't dig in as much. And flip it over and do the same this way. So that's pretty much now what I'm after. What I will do at this point, just for a sort of semi-finish, I'll take a piece of emery cloth over the file and give it a little clean up. Right, it's not bad at all. I've just got a few slightly deeper file marks in here, so I'm going to take these out using a sharp little needle file. That one should do the job, and this just allows me to work down and take sort of semi-deep scratches out without putting in any bigger scratches that you might do going back to the earlier file. And draw filing with needle file is one of my favourite finishes to leave, really, on these kind of edges. Enhanced further at the end by wrapping some emery cloth around. So these two succumb to bits getting stuck in them. And often that's actually what puts the scratches in. Right, finish up then. I've got a file here that cuts much better than it looks, and I'm just, as it goes through, I'm using a rolling motion. Okay. You can see I've ended up with a slight bit of curvature on that line, and if anything it's pointing slightly down that way, so that tells me I've created a bit of a convex there. So I'll actually just go back to this and take that out. I'm going to aim for the high point on the convex and keep going till that line straightens out. So that has put on the top profile, and I'm now going to attack the sides in turn. First of all, I'm going to get it like this, and I'm going to be filing across. I want the file marks going this way, but I have to be careful here, because if the file digs into this surface going across the file marks, it will take a lot of getting out. File marks or troughs, whatever you want to call them, going in line with the file strokes are quite invisible. They'll be there'll be deep scratches going this way, but providing all the scratches go that way, you don't tend to see them. However, if I come this way and put a deep scratch in, it will become incredibly obvious and very difficult to get out by filing again. So I've got to watch it as I come up to this edge. Initially, I am just going to take the solder off and try and find an amount of flatness. With small sections like this, I tend to use a finger on top of the file just to help me align it. It's very easy over a short distance to end up off. So right, so I can see now I've got a bit of work to do, but not that much. But the main danger here is coming too far down and putting scratches acrossways. You could try and cover it with some masking tape or something if you felt that would help, but I'm just going to be careful. In many ways, what I do is, instead of aiming to blend it exactly on the line, I actually work just behind it, and I find naturally the thin edge disappears anyway. So I'm almost going to aim to leave a millimetre unfiled, and I will naturally find that ends up sort of falling off. I now got a little more confidence in how the level lies. I can extend the stroke a touch. Right, now that I've got that looking something like, I just need to sort this blend out, and rather than take the whole surface down, I'm just going to try and curl in on the top. So for now I'll proceed with this file carefully, and I'm just going to use the non-safe edge so that I can actually cut down into it. I'm going to start about a millimetre back, and I'm going to tip the file up and start putting pressure that way. Now that I'm very nearly there, I'm going to use a little file and just saving grace with all this is it's entirely visual. What I'm actually doing here is destroying all precision flatness. I'm just digging out bits where I want to see no scratches, but that's the name of the game with this kind of cleaning up operation for visual areas. So I just want to put a slightly more pronounced roll in on here. Deburring done, and I'm going to draw a line at that as far as the hand finishing goes, and I'm going to proceed with the rest of the manufacture. One day I may grit blast these surfaces along with the other casting-esque components, but if I do that I'll leave it until just prior to painting. In terms of machining then, I have a few more steps to go. I've got to put these holes in, I've got to do the chamfers, and I've got to take the thing to overall length, and I'm going to do that by working off the chassis, and I'll show that procedure in a moment. I thought, however, I'd just take this moment to discuss one topic that was raised in the comments and comes up occasionally, which is why silver solder instead of TIG weld. Silver soldering, you've got to pin everything or set it up carefully so it can't move. You've then got to heat it all up and pickle it and then clean it all up, whereas TIG welding, you can just TIG weld it. Well, there is a very simple answer to that question in my case, which is that I don't have a welder. However, to give this discussion a bit more of a rounded approach, let's think of a few things. So first of all, what do you want the finished thing to look like? You can see here I've gone for basically invisible joins. Once this is painted, you won't see any joins at all, and that with silver solder is pretty easy to do, because the silver solder is easy to file and it doesn't actually affect the geometry of the parent metal. TIG welding, you could TIG weld it and then file it back, but first of all, TIG welds can be very hard, and second of all, quite often they leave heat affected zones, and you may find if you do file back to the parent material that there are small undulations where the metal has shrunk. So okay, that's one thing. What if, however, you were happy to see the TIG welds? Well, for most components that would be fine. You could neatly weld it up and do it in a presentable way so that the TIG welds are almost a feature. That would be fine. However, for these kind of steam vehicles, locomotives, traction engines, etc., that wouldn't be a typical form of appearance to see TIG welded beads all over the place, and you could probably consider it sort of outside of the genre. So for me, if I was going to TIG weld it, I would want the TIG weld to be invisible. That would mean filing them off, and I find the silver solder much easier to deal with in terms of filing. But certainly TIG welding shouldn't be ruled out in some locations if you have one. Also, I remember this discussion a while back, and somebody mentioned the fact they actually do use a TIG welder in these kind of model engineering scenarios, but what they use the TIG welder for is to tack everything in place. So instead of doing as I did, having to put pins and work out how it's not going to move during soldering, you can just tack it together as an assembly and then silver solder with confidence because it can't move. So there's a few bits for thought, and with that, let's head to the milling machine and start milling. I am sandwiching this between two blocks again, and I say again assuming you watched the previous video, but I've left a small gap under there for the drill point to break through into, and I will now get this in the machinist's vice grip and put it in like that. Okay, I'm going to square this face up and then proceed to work on here. Right. Can you see that from where you're sitting? I don't believe it. I rolled it within a thou, and that is definitely speaking of reading. If I'm ever unsure whether the clock's moving or not, that's what I tend to do, just go one way or the other around the point it's measuring, and you know then that it's definitely not maxed out. Plus a thou. I will now proceed in fast forward to do the edge finding and then all the drilling. Holes all in, and you might have noticed I added a G-clamp for some extra support, just because if you imagine the way the profile disappears there, the actual bit being gripped by the vice is a bit on the small surface area side. Right, I've now got a milling cutter in here, and whilst it's set up I'm going to put a slot in, and you'll see what that's for in a bit. The flood coolant on this machine really needs changing, so for now this carbide cutter will be okay with a bit of oil. To put these chamfers on, I'm going to do the following. I'm going to release the vise from its current position. I'm going to square it up, and now I'm going to use a angle block to sit it up at the right angle. I'm aiming to get it as low in the vise as possible, but also keeping it reasonably central, which is a bit of a play off in this case. Okay, something like that. Give it a quick clonk, and yeah, okay. Feels a little on the slow side. Seeing as it's not greatly supported from underneath, I'm going to go down in little slivers. Going back to the filing topic earlier, this is a good example of where you can actually do your deburring in the vise. With a few tools to hand. I find it worth putting something over the cutter just in case of any slips. Ta-da! Now to finish these motion plates, I've got the chassis out as a guide, and forgive the odd bit of sawdust or cobweb, it's been under the bench for some time. But let's have a think about what I'm going to do next. So somehow I have to finish the overall height of these, and it's worth noting that the top surface here should be in line with the top of the chassis when it's finished, because it's going to support the running boards. Now also this face here has to be in the right place for the cylinders, because as I may have pointed out in the last video, these 4 fixing holes here line up with this bit, and this whole thing is going to go on the side of the chassis like that. So I could just work to the dimensions on the drawing, but unfortunately they're a bit vague, and because of this 1.5 degree angle, actually dimensioning an overall height isn't that simple without some kind of gauge point or more specific dimensioning, and the dimensions I've got are, as I said, a bit limited. So what I'm going to do is use this as a guide. So let's bring the camera in a bit closer and see what I can come up with. To position the cylinders, when I was making the chassis, I put in these 2 reamed holes, and they align with these dowels and set the timing. Now with that in position, everything else is then being sort of built around the cylinders, as I'm about to demonstrate. But first of all, I'll put this on here. So that has set the cylinder's position, and by the way, the bore is designed to align with the middle driving wheel in its central suspension position. that's why it runs downhill. And I'm just going to put one cap head in there just so it can't fall off. Okay, and now it's a reasonably straightforward procedure of lining these holes up. Now I could mark it out perhaps, or put a bolt in there, but I can actually see quite clearly by looking down the holes. So as you can see there, I've pincered it in place with a little toolmaker's clamp in such a position that all the holes line up, and this can be done more precisely come the final fit up. For now all I'm doing is pincering this here so that I can measure the drop from this milled edge back to the top of the chassis, and then I know at the milling machine how much to go and take off. So that's the key bit to show here. I milled that slot in earlier so that now I've got something to measure to, and I can go and finish these with confidence that the finished thing is going to line up come the day of the assembly. So with that in position, I can pick the whole chassis up. And now I can come in and measure what the drop is from this height to this height. Okay, now this stylus actually has a nice teardrop shape on it, which makes it a bit more suitable for measuring drops, because it accounts for the cosine error. Let's see here, that's 5, 10, 15, 20, 22 thou. Just make sure that that's not the extent of the range. Oh, actually, well, it's close, but it does actually go to 24. So 0, call it 22. And what I'll do actually, just to check this, because clocks aren't always accurate over a drop, or let's say a lever clock isn't, I've got here a set of feeler gauges, and if I can find something suitable we'll verify the measurement. With a 22 thou feeler gauge I've re-zeroed the clock, and let's come over here. Okay, I'm at 1,000 amp, so I'll take 21 off because I think it's more accurate to compare across two heights that are similar rather than measuring over that drop. So 21 thou, I'll write that on here, then I go back to the milling machine, set it up, edge find off here, 21 thou, and that's that one done, and I will of course repeat the exercise for this side. And there they stand, a pair of finished motion plates to my own design. So I am now going to proceed with the cylinder block assemblies and get all the crossheads, spindle valve guides, etc. finished, and get the cylinder blocks working as a pair of mini assemblies. At that point I'll then look at attaching all this to the chassis. Well, that concludes the motion plates and also the video for today, so thank you for watching. I hope you found this interesting, and see you on the next video.